Only this chapter for the integration?
No.
More chapters.
Okay. By parts now. Okay? You ready there?
Yeah.
So, in by parts, let me give you the idea of the problem we're dealing with here. So we know what the integration here is. What is it? EX plus C. And what's the integration of cos x? What is it? Sin x plus C. Yeah? But in fact, what we don't know, and maybe it seems like we should know it, is what this is. And I'm telling you now, it's not EX sin x.
Some like tool?
It's some type of rule, like the product rule, yes.
So the should for EX plus
No, what we're looking at now is how do we integrate when we have two functions. Well, let's really just say function. What we want to know is what do we do in this situation when we have a function multiplied by a function. So like you said, Karar, it's like a product rule. It's not the product rule, but it's like a product rule.
It's a product rule multiply two functions.
For derivative.
But
Yeah. Yeah. Get the idea? Yep. So, what I'll do, I'll give you the rule and then we'll prove it. The proof is actually quite simple. So the rule goes like this. If you have two functions, f multiplied by a function which we call g derivative, the rule is this is fg minus f derivative g dx. And the proof is really easy. The proof now, if I differentiate the left, the derivative and the antiderivative, they cancel, don't they? So you're just left with f times g derivative. What rule do I need here for the derivative for this one? What rule?
Product.
Product. So what do I get, KJ?
F inverse F times G inverse.
Why are you saying inverse?
Sorry, F times G.
No.
F plus G.
No. F derivative.
Sorry.
Wakey wakey.
Because of that tick.
F derivative G. Go on.
Plus
Yeah.
F
Yes.
G tick.
Derivative.
Yeah.
And then when you differentiate this, it cancels the integration and you're left with this. Which cancels that. Ends the proof. Now, there are many ways to write this formula. So I'm going to write the three different ways I know. So, if I can go down. The first way is integrate an fg derivative. That's equal to fg minus f derivative g. Second way you can write it is using u and v. So you can have here u dv dx equals uv minus du dx v dx. And the third way of writing it is u dv equals uv minus v du. In fact, they all mean the same thing. Okay?
Okay.
So for example, the differences are not really anything, but this is what I use in class. Because it's the easiest to write, I find it the easiest way to do it in class. This is what's in the formula book. It's written like this, and this is what I learned in school. But they all mean the same thing. So let's have a look at an example of using this rule. Let's use it on the original function I had, integrating sine x, no,
Example.
yeah, an example, cos x times ex dx.
You're going to use number A.
I use a in class. Yeah.
Cos X.
Is this okay?
Yeah.
Yeah. So what you do is you call this piece f, and you call this piece g derivative. And I usually make a little table here where you have f derivative, g derivative. Yeah?
Okay.
So what's f? Cos x.
Cos X.
And what do I write here? In the g derivative spot we write ex. So far is that okay, what I'm doing? Yeah. So we fill in the missing information. If f is cos x, what's f derivative?
Minus sin X.
Minus
And if the derivative is ex, what was the original? In other words, yeah, it was ex. So just be a little bit careful here. When we move down the table, we are differentiating, and to move up here, we are anti-differentiating. In other words, we're integrating.
integration.
Yeah. Okay, if you got this table, can I go down?
Yeah.
So the rule is this equals fg minus f derivative g. So what's f here? Cos x.
Cos X.
And what's g?
G is EX.
Ex. Minus f derivative, which is what?
Minus X.
Minus sin x, and g, which is ex. So we get this equals ex cos x plus integrate sin x ex dx. Now you might be thinking this has not helped because what's happened? You still have an integration. Yes? But let's just remind ourselves what's our integration we have at the beginning. What was it? Integrating ex cos x, wasn't it? Yeah? So what do we have as an idea? Well, what we could do is we could use the rule again here.
Again.
Yeah. But wait. Before I do that, I think this example was maybe a little bit too difficult to start with. So what I want you to do is just leave a little bit of a space. We'll continue it in a moment. Let me just do a simpler example first. Okay? Yeah? So just leave a bit of a space. About this much space, okay?
Okay.
Right, let's have a look at a little bit of a simpler example first. I should have started with x sine x. Okay, let's make the table. What's the f here? F derivative?
X.
1. G derivative? Sine x. And g? Minus cos x. So the rule is, what's the rule? It's equal to fg, yeah? Minus, so first fg. So what's fg here? What's fg? Minus x cos x. Minus f derivative. What's f derivative?
After derivative.
1 times g. And what's g? Minus cos x. So that becomes a plus cos x. Now in this example, we still have an integration. But what has happened to the integration? It's a simpler integration, isn't it? What's the integration of cos x? Sin x. So this is the answer here. Yeah? Okay, let's do one more example before we go back to the difficult one. So suppose we have x squared ex dx. Okay. What's the f here? What's the f?
X.
X squared. F derivative? 2x. G derivative? Ex and g? Ex. So this is equal to f g minus f derivative g. Now what's happened here? Is it easy to do or not? What do you think? Well, this integration is still a product, isn't it? But what's the big difference between this new integration problem and the original integration problem? What's different? Is it the same problem? Guys, please look up at me. Look at me. KJ, Yemi, Takin, Karar. Everybody look this way at me. So I want you to do... KJ, I'm not that bad to look at, am I? look at me, please. What I want you to do is look at the new integration we have, the original integration, and tell me how they're different. What's different?
2x is different from x squared.
Yeah, so the power has decreased. But is it an integration we can do? Do we know the answer to this integration? No, because it's still a product. But if we use the rule again, maybe it will get simpler again. So we use the rule again, but this time we're using it on just this part. So I'll do my box over here. This time, what is the f? 2x. F derivative? 2. G derivative? Ex and g? Ex. So the piece at the start is still the same. Then I have big brackets, and now I use the rule, which is now fg minus f derivative g. Now look what's happened. This one now is easy to do, isn't it? I can just take the 2 outside. What's the integration of ex? Oh, come on.
Ex.
Plus, this will be plus 2 ex. minus 2 and then plus 2. So what did you say, KJ?
EX.
EX.
Oh.
What's in common here? What's in common?
EX.
EX. So if I take the EX out, I'm left with x squared minus 2x plus 2. So this is the integration.
Why did I change the plus
Why did what change the plus?
and the minus?
This one to here
Yes.
might have something to do with this one here.
Okay.
Maybe we need to use it 3 times?
Yes. In the exam, this will not happen. The limit for the exam is twice.
Brilliant.
So, integration by parts. This is how I think about it. Can I go down? When you're ready. Yep. So this is how I think about integration by parts working. What you start off with is something which is difficult to integrate. Yeah? And then what you do is you use by parts, and then what you hope is that you get something which is easier to integrate, but there'll be an extra function stuck on the start. But you don't care about this because this is part of the answer. You just are worried about this part. And if it's still difficult, you can use by parts again. So you could do by parts again until it becomes easier. But each time you do by parts, if you had to do it again, you'll get another function. So if you did by parts again, you would end up with like a function plus another function plus something which you hope is really easy to do. So you keep going until you get some integration which is very easy to do. Like in the last example, what integration did we finish with in the end? Just this, wasn't it? Which is easy to do. Do we get the idea here?
Yeah.
So now, as promised, let's turn back to the original one we were looking at. Now, you might think we've learned that when the integration is still difficult, what should we do?
Do it again.
Do it again. So let's see what happens now. So this is EX cos x, and I'll make another table here. So the f is equal to sine x, the f derivative is equal to cos x, the g derivative is equal to ex, and the g is equal to ex. Yeah? Right, let's see what we get. So this equals ex cos x plus big brackets f g minus integrate f derivative g. Now I think I have a sign mistake here. No, I do not. So now you get here ex cos x plus ex sin x minus integrate ex cos x. Now what's the problem? What's happened here?
It's not going anywhere.
well, well put, KJ. It's not going anywhere. Is this still difficult to do?
Yeah.
Yes. In fact, it's as difficult to do as the original because
It's like the same thing with the original.
not it's like, it is the original. And in fact, that's perfect because watch this trick. Because it's the same as the original, I'll take it over to the left. And on the left I have the original plus this new one, which is the same as the original, equals EX cos x plus EX sin x. Now look at the left. These two are the same, right? So I can add them together like this.
Manipulation.
That's right. And then, what should I do next? Maybe I divide by 2. And what's in common here, by the way? EX, isn't it? So, in fact, getting the original again here was good. It helped us. It wasn't actually a bad thing, it was a good thing. Mm-hmm. Continue?
Yes,
Yeah. Continue? Yeah? Yeah? Okay. So, true or false? Tell me this. True or false? True. Because this is EX multiplied cos x and this is cos x multiplied EX. They're the same thing, of course, right? Yeah. But in fact, one problem is easier to do than the other, even though they're the same. You might think, what's the difference? Well, the difference is in this one, the E is F and the cos x is G derivative. And here the cos is F and the E is G derivative. Now, although you'll get to the right answer, there's a little trick here for deciding which is the best order. In other words, sometimes problems are like, okay, I'll give you a good example. Like this one here. We did this one earlier, didn't we? What answer did we get? What answer did we get for this one? Didn't I do x sin x? Okay, so we did get an answer, yeah? Now watch this. And I did write it like this, x sin x, didn't I? Watch what happens if I swap them. Sin x, x dx. So, in this version, you don't need to write this down, just watch. Here, what's f? Sin x. F derivative, cos x. G derivative, x. And g, What's G? I'm waiting. 1 over 2 x squared. So if I use my formula, this will be f g minus f derivative g. Now, if you compare that when I did it earlier, here, look, after I used the by parts rule, this piece here was very simple to do,
Okay.
wasn't it?
Yeah.
Whereas here, now instead of making something simpler, I've made something just as difficult. So, if I use the by parts rule again, we can get to the answer, but it has taken us longer. So there is a best way to order them. So when you're trying to figure out which one to write first and which one to write second, what you need to remember is this, L-I-A-T-E. So this you need to write down like a latte, liate. Give me one hot liate, please, extra chocolate. Right, so the way this works is, the L means you should always write logs first before anything else.
Mm-hmm.
The I means you should always write inverse functions next. And by inverse functions, I mean sine inverse, cos inverse, tan inverse. Not this. A stands for algebra, or algebraic. So these are things like x, x squared, x cubed, and as you said, KJ, in fact, 1 over x and 1 over x squared. Yes?
Copy.
Hey! Oh!
Which one is this? Blue.
Green, I think.
Alright.
I think. Thanks. T stands for, what do you think? Trigonometry. So that's sine, cos, and tan. And E stands for exponential, or E, EX. Yes, so here in this example, this is a T and this is an A, and this is the wrong order. The A must be before the T.
But in the question we did, that one, that EX was first.
But you notice I sneakily swapped them around without you noticing.
So this exam I can't swap.
Oh yes, yes. Before you start the problem, you may need to swap them
Fine, I
around.
got the same result.
But you will get there longer.
Yeah.
That's fine.
Yeah, I mean like same result.
Yeah, but time will be an issue in the exam.
Yeah.
You know? Why take the long path when you can take the short path? You know? That sounds like ancient wisdom, I'm sure. Why take the long path when you can take the short path? Now there's one other type of problem I want to show you for this. One last example for this. What's the integration of log x? What is it? Anyone know?
1 over ln x.
No. You don't know because we haven't done it. We've only done the derivative of log x. What's the derivative of log x? 1 over x. We've not done the integration. We can use the by parts method here. However, you might protest. What is the problem with this?
There's no product.
Exactly. So how can we fix that? How could I force it to be a product so I can use by parts?
Multiply by 1.
Yes. So you write this as 1 log x.
Only serious bro.
Now, is 1 L-I-A-T or E? What do you think?
E.
Yeah. And this one?
E.
Try again. You're
L.
losing your roll, you're falling downhill. L. So this is, should be written as log x times 1 dx. Using our table, this is f is log x, f derivative is 1 over x, g derivative is 1, and g is what? I'm waiting. What's the g? What's the g?
X.
Thank you. Keeping a cliffhanger. Right, so this will be f g minus f derivative times g. Now look at how nice that integration at the back has become. It's just integrating 1. So we all know what that is from 10 seconds ago. What is it? That's right, x. Yep. So you have the answer. It's x log x minus x plus c is the integration of log x. Something you would not have guessed.
Yeah.
Seems simple, no?
Does it now? Does it now really? You got that? Well done? Yep. Yep. In the exam, all the examples I did with you are all examples. In fact, the easy ones, which I did briefly, they're too easy for the exam. So the exam ones require you to usually use the rule twice. Usually after using the rule twice, the problem has become simple enough. Or it's back to the start and then you have to take it over to the other side, the original. The other type of problem you get in the exam is like this, where it doesn't look like you need the product rule, but you do. Last time this question came up, nobody got it right, because nobody remembered that the by parts, not the product rule, the by parts rule could be used for something which isn't a product.
Well, I knew that.
Yeah, but this is in class with my help, okay? I'm sorry to tell you this.
Well, I said.
You gotta tell me now.
Yes, okay. Okay, fine. Fine. In June, we'll see if you remember. So nobody remembered that they could use by parts for problems which aren't products as a technique. So far we have 2 techniques for integration. The first technique is by substitution, and the second technique is by parts.
About rational.
Yeah, well, the technique we used was a substitution to solve it. And there's still one more technique, which is called partial fractions. Okay. The integration question, some people like it in the exam, some people don't. It's just what you prefer. I think it's usually a good question if you like calculus.
This one is good. I have to like calculus.
As engineers, you
have
really
to
should like calculus, because I guarantee you, you will be seeing it for the next 4 years.
The next 4 years.
Definitely.
Yep.
Oh.
Oh my god. That's true.
Well, it depends where you study. So, you'll see it for the next 3 to 4 years.
No more statistics and probability.
No, let's do that too again. And in fact, we have a little bit at the end, I think, for it. We do. I'm sorry. Look, the page 84 onwards. Look at these beautiful histograms I made for you.
Okay. Oh, okay. Ah, the statistics.
Look at those histograms I made for you. Look at them. They're delicious looking. Look at them. Right. Yeah. What I would, what you really need to be practicing here in, let me just explain. In question 1, I think you only need the rule once. In question 2, it looks like you need the rule twice, and in number 3, you need the rule twice as well, but the original reappears. And number 4 is like the last one, where there's a trick. You have to put in the 1 to make it a by parts. So you know yourself, my advice, you do 1 or 2 from each to make sure you understand the different types. So, I mean, you'd want to do like, something like AB, 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 or something, something like this, okay? 2 from each is what you need to be doing. Yeah. Alright, now what time is that class at? Are you sure it's at 3 o'clock?
Yeah.
Okay, no, it's actually 2 periods. Yeah, 3 to 5.
See, that's what I thought. It's a double
Yeah.
at 3.
Yeah, but we got one now at 10.
No, that's for replacement for the one tomorrow. So you don't have a math class tomorrow evening.
Why?
Yeah. Well, this is good news. It means your class tomorrow at 4.
Will be cancelled.
No, not cancelled. You already had it at 10.
Yeah, I already have it, yeah.
So you can go home at 4.
Is it gonna be like for the rest of the week?
No, it's just for this week because the biology teacher is not in today. So we have to swap physics. We have to swap biology, and as you know, when biology moves, physics moves too, because they happen at the same time. So this is what happened. Okay? Right. So 3 to 5 is double.
Double physics, right? One
Uh,
maths, 1 physics.
we'll do 1 physics, and we might make it a double, depending on how we get on. It'll either be 1 physics or 1 physics and 1 maths. Sorry, it'll either be 2 physics or 1 physics and 1 maths. It won't be 2 maths.
Definitely.
Definitely won't be 2 maths.
So far.
Now, I'm saying that now, and then come 3 o'clock, I could walk into the room and say, change my mind, it's going to be 2 maths. But right now, I'm not planning for it to be 2 maths. Okay? Alright, I'll see you later, so.
2 maths will be so far ahead.
We'll be
One thing that
rocking ahead.
the materials